Welcome to the Design to Manufacture Digital Tools class. In lecture one, we'll just overview the design process and set into context the content for the course as well as the kinds of skills related to design that we will learn during this collaboration over the semester. My name is Sundar Atre. I am the Endowed Chair of Manufacturing and Materials at the University of Louisville. And recently, I have taken on the role of director of the Additive Manufacturing Institute of Science and Technology, AMIST, focusing on 3D printing related research, teaching, and applications, covering 3D printing for healthcare, transportation, construction, and defense. Let's see how these areas of interest combine with the digital tools that we will focus on. You have gone through Introduction to Material Science courses earlier on. You start out with atoms, you go into crystals and dislocations, and if you're still awake, you go to grains, phase diagrams, and then finally you come to their relationship of those microstructures and composition to various mechanical and other functional properties. And then those enable an end use such as this bike. This kind of a science-driven approach ends up, especially for mechanical engineers, a huge burden because if you didn't know where you're going to use it, it feels like sitting in a physics or chemistry class. And while there's nothing wrong with that, when you took mechanical engineering as a major, this is hardly like the inspiring approach to understand how you make things better, for instance. So we will, in this class, look and through the whole course, look at how to go from an end application in mind and go backwards to figuring out what are the best materials, what are the best ways to manufacture them, and what are the fundamentals that govern eventually uh, how compositions get affected in terms of enabling new applications. So it's going to be a design driven approach to studying materials. So, what is a design process that we might be familiar with at this stage? Right? There's a need for a product, and so we try to address what is the problem that is getting solved, and in order to get to the product specification we go through an iterative process where there's a general concept based on how things might function, what it might look like, what the principles that it might be based on, and then we go into the embodiment in terms of laying that out into a form, into an assembly, and then finally work out the details in terms of how it's made, what it is made of, how much will it cost, will it work well enough. So when you look at this type of a process in terms of going from the market need to the product specification, from design tools, there are many things in terms of how to be able to come up with the appearance of something, how to be able to do some stress analysis and functional analysis, different kinds of simulation tools, maybe even throw in some cost and do some FEM and so on. But what we really are looking for in this course is everything needs to be made of something, materials. Right? How does, at various stage in the design iterative process, do we begin to down select what material might work? How do you then maximize the properties based on the constraints and then combine materials that are amenable to manufacture and come down to one priority recommendation? Right? How do we go through those kinds of process? So, for instance, to illustrate the problem at hand, here is a bottle. In this case, it's wine. Right? I used to live in Oregon, red wine country, before coming here to bourbon country, but the deal is the same. How do we get this content from here into this glass over here? There are various different ways you can do it as a mechanical engineer in terms of designing an opener for this cork. Right? For instance, in A, you can apply a tensile force, in B, you can apply a shear force, and then in C, you can have a needle go through, and then there's a pressure that's applied below that ends up popping the cork. Let's take a look at the tensile force based concepts. And when you do that, again, you can have a direct pull, a lever, you could use a gear system, or you could use a spring. And all these could impart different types of tensile forces and get to what you need, which is basically pour the contents of the bottle into the glass. So let's take a look again when you finally look at levered pull. And so now you get into details in terms of the embodiment. Right? So you have to apply a certain amount of force. What does it look like? So this grip will be made into these kinds of dimensions to satisfy the strength requirements. This grip will be made out of a plastic. It's called phenolic, and it will be manufactured through a casting operation. And then the portion over here for the lever will be made out of a stainless steel. Okay, and it will be machined from bar stock and it'll look in this kind of shape and we have these kinds of dimensions. The focus of the course is how do you then decide what to make this material from, and what the dimensions are, and then how to make that. Similarly, in the second case, why do you select a metal instead of a polymer in this case? Right? How are these choices made?